So if we were going to graph, this exponential function, it would have an asymptote of y equals 0. And have a y-intercept of 1, and it'd be a growth graph, assuming that a was greater than 1. And now I want to graph this graph. Well, the relation between this green graph and the red graph I'm about to draw is that they are inverses. And if you remember, when we did inverses, we reflected everything across the line. Y equals x. So all the x's become the y's, and all the y's become the x's. So this horizontal asymptote at y equals 0 becomes a vertical asymptote at x equals 0. And this y-intercept of 0, 1 becomes an x-intercept of 1, 0. And it's going to reflect like this. So now I can go over here, and the domain is going to be 0 to infinity. And the range is negative infinity to positive infinity. And it has an x-intercept of 1, 0. And so then I highlighted some important stuff. The description, this is a one-to-one function, so it has an inverse. The y-axis serves as the vertical asymptote, which is the x equals 0. And this is a continuous function, and its inverse is y equals a to the x, which is what we graphed first. And then make sure you remember your rules about shifting. So down below, we're going to talk about how to graph an exponential by hand, or a logarithm by hand, because you're going to have to do that. So we're pretty much going to follow these steps right here. Construct a table using the exponential, using the loop, trade the x and y values, make a table, then switch the x and y values. So this is in log form, and I told you in the video earlier today that if something's in log form and it's not helpful, put it in exponential form. So I'm going to convert this to exponential form, so start at my base 2, and I'm going to make my little swoosh or my loop around the equal sign. So I now have 2 to the y equals x. And I'm sure you're looking at that and saying, well, the y is in the wrong place, so that's why I'm going to do letter B. I'm going to trade the x and y values. 2 to the x equals y. And then I'm going to make a table. And I'm going to plug in, let's plug in negative 1. If you plug in negative 1, you're going to get 1/2. If I plug in 0, I'm going to get 1. And if I plug in 1, I'm going to get 2. And 2, I'm going to get 4. Before you graph, super, super important, you need to switch the x and y values in the table back around. Otherwise, what's going to happen is you're going to end up with an exponential graph, and we want the inverse, the log graph. So instead of graphing negative 1, 1/2, I'm going to graph 1/2, negative 1. Instead of graphing 0, 1, I'm going to graph 1, 0. And then 2, 1, and 4, 2. So now I can see my graph. It's going to look like that. Okay, so let's do something a little bit more challenging, because you know the problems on your test aren't going to be that easy. So I'm going to do the same thing. I want to graph this. I'm going to rewrite this real quick. I have y equals log base 2 of x plus 1 plus 1. All I did was move this 1 to the end. You cannot make your little swooshy until you have only a logarithm over here. So the first thing you have to do is move this 1. So now I have y minus 1 equals log base 2 x plus 1. And now you can start at your base and make your swooshy.